this this video is going to be video A for section 7.4 because it's pretty long, so I'm going to make it into two videos. This one is we're just going to cover the multiplication on this part of it, and there is a very important property right here at the top of the page. So this is a concept that we have to understand because it will save us a whole lot of time. When you square a radical, that means you're going to multiply that radical times itself. So if I take the square root of a and I multiply it times another square root of a, I can multiply my two a's together and the answer stays under the square root symbol. So I'd have the square root of a squared. A times a would be a squared. And you just keep it all under a radical again. Well, that means if I take the square root of the variable, remember there's a 2 there, and I'm going to divide the powers. 2 divided by 2 would just give me a to the first. But notice what happened. If I multiplied the 2 together, the answer ended up being just the letter that was under here, and you just pull it out and it doesn't have a radical on it anymore. So if we remember that that is a pattern of what happens when you multiply radical expressions, this property is important. It saves time. So if the radicals are the same, just pull out the number. Okay? Oops, that's not what I wanted to write. Pull out the number from under the radical. Okay, so if I have the square root of 7 times the square root of 7, that's going to be the square root of 49, but the square root of 49 just comes out to be 7. So whatever it is, if they're exactly the same, you just pull that number out. So we basically can leave out showing this step that's right here in the middle. So if I have the square root of 3x times itself, or the square root of 3x times the square root of 3x, I'm just going to end up with 3x. Because 3 times 3 would be 9, and x, that would be 9x squared. Then if I take the square root of each one of those, it just comes back out to be this. So this allows me not to have to go through the simplification process. Just know that when you multiply a radical times the exact same thing, you're squaring them, you just pull the number out. Whatever's under the radical just comes out. So now here I'll have square root of y times square root of y. I'm just going to pull out the y because then it will just be a y. This would be square root of y squared, which just becomes y. So we're going to use this property, and you have to remember that when you're going to work with multiplication. Now, the very simplest kind of multiplication is just like when we multiply polynomials. But you're only going to multiply the coefficients times the coefficients of a radical, and the radical times a radical. So like here, if we're multiplying something under a radical times something else under the radical, you're going to multiply the numbers together, but the answer is going to stay inside of a radical, unless it could be simplified. But the multiplication process says under radical times under radical equals under radical. Now, if it's got a number outside and a number inside, you're going to do the outsides and keep them outside, and the insides and keep them inside a radical. So basically, outside times outside, and they stay outside, and inside a radical times inside a radical, and the answer stays inside the radical. So you go through this multiplication process, and if the answer at the end comes out to be something that needs to be simplified, then you have to do that. So that's a little bit after whatever we do to multiply with. So using this same idea, if I have a times b, I'm going to multiply those together. So here I have 3 times 7. They're both under the radical. So I'm going to multiply them together because they started out under a radical, their answer ends up under a radical. Then you have square root of 21, but 21 doesn't have any perfect square factors, so that's your final answer. This is it. That's it. You're done. So here I have a number under the square root and a number under the square root here. So I'm going to multiply them together. I'd get square root of 50. But then, is the answer a simplified radical? Well, 50 has a perfect square in it, so we would have to continue going on this one. we'd have to look at the fact that that's 25 times 2. So now I'm going to take my square root out of the 25 and bring it outside, and I'd end up with 5 square root 2. So these two numbers combined to make 50, but once we put those numbers together, we ended up having a perfect square that we have to fix. So the square root comes out of the 25, leaves a 5 outside, and then we're just left with square root of 2. Okay, so here I have some numbers outside and some numbers inside. So I need to go back up here to this rule. So I'm going to do my outsides together. 5 times 7, that'd be 35 on the outside of the radical. And inside numbers were 5 and 2, so that leaves me with 10 on the inside number. So can the square root of 10 does it have anything with perfect squares? Well, 2 times 5, and neither one of those are perfect squares. So your final answer is just 35 square root of 10. Okay, now here, your coefficients outside are fractional values. So you have 3/4 times 2/9. Now, just go ahead and multiply straight across and then reduce what you've got. So I have 3 times 2, which would be 6. And 4 times 9 would be 36. So I have 6 over 36. And inside, I have radical with 6 and a radical with 2. So my under the radical part is going to be 6 times 2, which is 12. So now let's go back and look at this. 6 over 36 is going to reduce down to be 1/6. And the square root of 12 can be broken down because that could be 4 times 3. So now I'm going to take this 4 and I'm going to get its square root. So I'm going to have times 2 square roots of 3. Now, we have to think of this as being over 1. So when we multiply together, I have a 1 times a 2 because these are outside numbers. This just doesn't have a square root on it. So 1 times 2 would leave me with 2 square roots of 3. And on the bottom, 6 times 1 would be 6. Now, these two numbers work like any fractional value that you have. 2 and 6 can be simplified. So I need to go ahead and reduce that fraction out, and my final answer would be square root of 3 over 3, because that would be actually 1/3. You can keep the 1, or you don't really necessarily need it. So fractional times multiply the fractions together, and then work on simplifying, and continue to simplify until you get it down to this last phase. So here's your final answer. Okay, so this is the very simplest stage of multiplying. So basically we're going to take the things we learned from this and we're going to apply it to other processes. So the next phase of multiplying is when you have a radical expression outside, but then you have a binomial expression or even a trinomial. In this case, we're going to limit it to only 2 inside, so that's a binomial. But what that means is I'm going to take the 5 square root of 2 and I'm going to multiply it to the first one, and then I'm going to take it and multiply it to the second one. So this would be 5 square root of 2 times 2 square root of 3, and then I'm going to take the 5 square root of 2, multiply it times the 4 square root of 5. So I'm distributing the 5 square root of 2 to both radicals that are inside the parentheses. Then it's just like regular distributing process, but we're working with some radicals. So now go back and you've got 5 times 2 would be 10 square root of 6. And then over here you've got 5 times 4, that'd be plus 20 square root of 10. Now it says to add, but our addition, we can't add things that don't have the same radical. So a square root of 6 doesn't have any perfect square numbers, nor does the square root of 10. So this would be the simplest our answer could get. It's just like the problems that we did with adding and subtracting in the last video. So if your radicals are not the same, you can't do it anything else. Alright, so let's see a few examples here and practice this. This multiplication and the problems on the next page are going to be the ones that you need to practice the most. So here, I'm going to put a 1 in front of that first square root of 3 just so that it kind of gives our mind thinking number outside times a number outside. So now I'm going to multiply 1 times the square root of, times 3 square roots of 7. So 1 times 3 is going to be 3 on the outside, and 3 times 7 would give me 21 on the inside. And I'm going to move to the next one. And I have 1 times 4, which would be 4 on the outside, and 3 times 2 would be square root of 6 on the inside. And again, my radicals aren't going to simplify because neither have perfect squares in them, and so they're not alike, so this would be your final answer. Really, all you're going to do here on some of these problems is just do the distributive property. Okay, on the next example, probably be helpful to put 1s on the numbers of the radicals inside the parentheses because they don't have a number in front of them. It's just a reminder, you don't have to have it, but in your brain you have to think it. So now I'm going to distribute the 4 square root of 2 to both. So 4 times 1 would be 4 square root of 6. And 4 times 1 here would be 4, and square root of 2 times 5 would be square root of 10. And again, 6 and 10 neither have perfect squares in them, and so they won't simplify, and the radicals aren't alike, so that's as far as you can go, and that would be your final answer. Alright, the next two, the same kind of problem. So here we're going to have 2 times 5, so I'm going to distribute here. 2 times 5 would be 10, but okay, go back up to the top and remember what happens when we multiply radicals that are the same. So look at what we've got right here. We've got a square root of 7 times itself. So that means all I have to do is pull the 7 out as a whole number, so I'm not going to have a radical on that first term. Then I'm going to multiply to the second one, and I get 2 times 8, so that's negative 16, and 7 times 3 would be square root of 21. Okay, so this is one you have to pay attention to. When you square those two radicals that are the same, it just comes out to be a whole number 7. So simplify that. 10 times 7 would just be 70 minus 16 square root 21. And there's your final answer. So anytime in any situation when you're multiplying the exact same radical, the radical's going to fall off and you just pull the number out. Alright, let's see what's going to happen on this one. Alright, 5 times 2 would give me 10 square root of 18. 5 times 7 would be negative 35. 6 times 2 would be square root of 12. Okay, now when I'm looking at 18 and look at 12, they do have perfect square factors. So I have to keep working these and reduce them out. Basically, it's like reducing a fraction. You've got another step to go. So now I can get a square root out of the 9. So that would give me a 3 to come out to the 10. So that would be 30 square root of 2. 12 can be written as 4 times 3, so that gives me a square root from the 4. So that'll be a 2 that multiplies to the 35. That'll be negative 70 square root of 3. So I've simplified everything, but because the radicals are different, I can't subtract the numbers, can't subtract the coefficients, so that's your final answer. So you distribute, you simplify the radicals that need to be simplified, and then there's your final answer. So this is just using a distributive property where you have one radical expression on the outside and 2 on the inside. You don't have to have both of them be radical expressions. Actually, you don't have to have any of them be radical expressions, but the process is what you're trying to do is practice multiplying radicals here. Okay, now the third phase of this is if we're going to have binomials in the radicals. with radicals. So I have a radical here that's a binomial, and I have a radical in this one that's a binomial. And so if you remember, when we multiplied binomials, we used the FOIL process. So let's just go back and think. If I have 5x plus 2 times x minus 4, okay, let's just practice first. So 5x times x is going to be 5x squared. The outer, 5x times 4, would be minus 20x. The inner, 2 times x, would be plus 2x. And the last would be negative 4 times 2, which would be negative 8. And remember, the inner and the outer is always going to come back and combine together in these kind of problems. So you should be able to do that phase in your head. You should be able to say, that's negative 20 and that's a positive 2, so this is going to come out to be a minus 18. So 5x squared minus 18x minus 8 would be your final answer when you FOIL those two together. So now we're going to do the same thing, but we're going to do it with radicals. Now I would put a 1 in front of it when there's not a number in front of the radical, just to ease your mind. Alright, so I'm going to start here. 1 times 1, so my first, I'm going to multiply first, outer, inner, last, and I'm going to write them separately like that. So 1 times 1, so that's going to be 1. 3 times 2 would be square root of 6. Okay, I'm going to go to the outer. So over here, this 9 does not have a radical on it, so it only gets multiplied times the 1. So there's nothing to multiply the square root of 3 by. 9 times 1, so this would be minus 9, and it just leaves square root of 3. So that's your outer terms. Then your inner terms, you're going to have a 5 times the outer number. 5 is a whole number, doesn't have a square root, so 5 times 1 would be the outer number, and square root of 2 would be the one left inside. And then at the end, you have the last two numbers, so 5 times negative 9 would be negative 45. Now we go back and we look and see, do we need to add or subtract anything? Well, we have to have like radicals to do that. So I have a 6 that has no perfect squares, I have a 3 that can't be simplified, and I have a 2 that can't be simplified. So nothing here can combine together. This one doesn't have a radical at all. So your final answer is just what you have here. So you can have the square root of 6, because it's got a 1 in the front of it, minus 9 square root of 3, plus 5 square root of 2, and the last would be minus 45. So none of these terms would combine together, because the things you're multiplying are also radically different from each other. Haha, radical. Get the term? Get the joke? Okay, same kind of problem. You can put the ones here if it helps you. You don't have to have them. And we're going to do FOIL. So first would be square root of 6 times square root of 5. 1 times 1, so that's 1 square root of 30. Okay, the outer, 1 square root of 6 times a whole number that's negative 3. So the negative 3 goes to the 1 on the outside. So that'll just be minus 3 square root of 6. Okay, that's your outer. First, outer. Now we need our inner. So here's your I number. The 9 goes to the outside number because it doesn't have a radical on it. So 9 times 1 would just be plus 9 square roots of 5. And then our last is right here, and it's just two whole numbers. 9 times negative 3, so minus 27. We can go back and look to add or subtract anything that's alike. This is square root of 30. Now, does that simplify? Well, it's got 6 times 5. Neither 6 or 5 have perfect squares. 2 times 15, neither of which have perfect squares. So 30 is simplified. It just looks like one of those numbers that it should break apart and simplify out, but it doesn't. So you have a square root of 30, a square root of 6, and a square root of 5, and that means nothing works. So this would be your final answer. You just get 4 different numbers on it. Okay, let's keep working. All right, I'm notice something right off right here. I'm going to multiply these first 2 terms, but they have radicals that are the same. So the 2 gets multiplied times the 8, which would be 16, but when I multiply the square root of 5 times itself, the radical's going to disappear, and I'm just going to pull the number out. So it would be 16 times a 5, and the 5 doesn't have a radical on it because it worked its way out right here. Alright, so that's my first. Outer is going to be right here. So 3 is a whole number, multiplies times the 2. So that would be plus 15. Oops, I'm sorry. What am I thinking? 6 square root of 5. Okay, then I'm going to go to my inner, which are going to be right here. So 4, negative 4 times 8 would be negative 32 square roots of 5. I got some square roots that match. And my last number is a negative 4 times a positive 3, which is going to be negative 12. So this problem has some different stuff on it because some things match up. Go back, and this is just multiply 16 times 5. 16 times 5, 5 times 6 would be 30, so that'll just be 80. Now I have some square roots that match. My square root of 5 times with my square root of 5. So these I can now combine together, positive 6 and a negative 32. 12 minus 6, so that would be negative 26 square roots of 5. And then I have a minus 12. Well, now I have a whole number here and a whole number here. So I have some more like terms. So I can go ahead and simplify that. 80 minus 12 will be 68 minus 26 square root of 5. So this one continues to have some work to do on it. You can't just multiply it and stop. You have to go back and see what can be combined together. So here, when we got the 5, we got the 5 because we had radicals that squared, which means just pulls a whole number out. So that this part doesn't have a radical. And 4 times 3 would be minus 12. It doesn't have a radical. So these two numbers come back and combine to give you 68. All right. Now, these next 3, this one, we talked about this earlier back when we were doing foiling at the very beginning. That square on the outside means everything in here has to be written twice. You cannot square the front and square the back and leave it. That's not what that means. You have to apply the rules of exponents. So this means I need the square root of 3 plus 5 times the square root of 3 plus 5. And I'm going to multiply them together and not just square the front and square the back. Okay, this is an important concept, and your teacher in algebra is going to be, she'll get upset if you continue to do that. All right, so I've got 1's in the front, and I'm going to multiply 1 times 1, which would be 1. But now I'm multiplying the square root of 3 times itself. So square root of 3 times itself means I get to pull out the 3 from under the radical, so it just comes to be a whole number 3. Then my outer is going to be 5 times 1, so it would be 5 square root of 3. The inner is 5 times 1, that'll be another 5 square root of 3. And the last is 5 times 5, which is plus 25. So I have like radicals in the middle. I have numbers on the front and the back that don't have any radicals. So this is 1 times 3, which is 3. Is going to add to the 25 that's back here. So these are like terms. I'm going to add those two together. That'll make 28. And here I have like terms on these because they both have square roots of 3. So I'm going to add 5 plus 5, and that'll be plus 10 square roots of 3. Okay, this multiply the square root times itself is a problem that makes people make silly mistakes. So be careful and realize that something in parentheses that's squared means it has to be written twice and FOIL it out. You can't just square, you got to FOIL. Okay? Alright, so this one is 2 2, but notice what's going to happen here. Do you remember what happens when the numbers are exactly the same and the signs are different? This is what we have when we ended up with the difference of squares. When we factored difference of squares, this is what happens. So again, we got a 1 on the front and a 1 on the front. So I'm going to multiply 1 times 1, that'll be 1. Square root of 11 times square root of 11. I'm just going to pull out the 11 because it's a squaring a number. Then I've got outer is going to be plus 6 square roots of 11, and the inner is minus 6 square roots of 11, so plus and minus. And the last is a negative 6 times a positive 6. So 6 times 6 would be 36, and it's going to be negative 36. Now, on the front, I've got an 11, 1 times 11, and on the back, I have negative 36. So these two I can combine together. So 36 and negative 36 and positive 11 is going to be negative 25. And here in the middle, I have a positive 6 and I have a negative 6. So these are going to cancel out. So it's just like when we multiplied before, the middle terms fall out. So all I'm left with is just a whole number. So anytime you're going to have a product that involves something like this, these square roots are going to fall out of the problem. It's a real handy tool that you use later in square roots that we are not going to have to do it, but it is something that's possible to use. These actually have a name. They're called conjugates. Okay, they're called conjugates. They have the same terms, the same numbers, with opposite signs. Okay? So, square root of 11 in both of them, 6 in both of them, one's positive, one's negative. So those are the name for those are conjugates. Alright, let's see what the last one is. 2 square roots of 7, 2 square roots of 7. 3 square roots of 6, 3 square roots of 6. So this is the exact same thing as we're doing right there. One's a plus and one's a minus. So we should realize that our middle terms are going to cancel each other out, which means all we have to do is the fronts and then do the backs. So when I multiply 2 times 2, I'm going to get 4. And square root of 7 times itself means I'm just going to pull out the 7 from under the radical. And then I'm going to have a minus, and it's always going to be a minus in between. 3 times negative 3, so that's negative 9. Square root of 6 times square root of 6. This time I'm going to pull just the 6 out. So I lose all the radicals. So I have 28 minus 54. And that looks like that should be negative 26. Is that right? Yeah, negative 26. Okay, so we're going to stop right here on this video, and this will be video A for 7.4, and then I will have another video for video B for the dividing part.